And now I'm unmuted. Good morning, good evening, or good night, depending on wherever around the world you are. And welcome to another fantastic episode of Microsoft Learn Live TV. I'm here joined by Marilag. Marilag, how are you doing?
Hello, I'm doing really well. Good to be here again, and good to see you, Alex.
Yeah, very good to see you too again. I was hoping to have another episode with you.
Yeah, so actually, when I signed up for this, I forgot that it was also you would be my co-host. So I'm so happy when I remembered a couple of weeks ago. Oh my God, it's Alex again. So yeah, I'm in the safe hands. So.
Now, the producers did tell me that there's a great audience here with us, and a lot of the audience members actually are newcomers to our series. So for them, I think it's important to say that this is part of a series. So if you want to learn more about Cosmos DB, maybe head back to the recording after the show because this is live. But Marilag, what about introducing yourself? Tell us who you are.
Hello, everyone. My name is Marilag Dimatulak, and I'm an Azure MVP. I'm super passionate about Azure. So I run a lot of communities, tech communities around Azure. So I run Azure User Group Denmark, Azure User Group Manila, and I also am part of a not-for-profit organization called ulap.org, where we also certify some of the underserved youths right now from the Philippines, where I'm originally from, but there's no reason for us not to do that for the rest of the world. And my day job, I'm actually one of the founders of a company based in Denmark and Manila, and my primary role is a cloud solutions architect. So
very nice. That's quite impressive. Quite the list you've got there.
Thank you
So much for doing that. And for those of you who don't know me yet, my name is Alex Mang. I'm a Microsoft Regional Director and also, just like Marilag, an Azure MVP, which stands for Most Valuable Professional. Don't be fooled, though. We do not work for Microsoft, despite our titles. My friends definitely know that I don't direct anything. I don't own a region of any sorts whatsoever. And I don't know about Most Valuable Professional, but I've done a few things in Azure as well. You have mentioned communities, actually, and I do want to bring up Global Azure, which is going to happen in roughly a month from now, May 5th to 7th. I'm also one of the members there. And if people want to sign up and speak for Global Azure, please do so. I'd be more than happy to have you on board. Good. So with that being said, actually, we have a fantastic topic today. I'm so excited about it. Marilag, how do you feel about change feed?
Me too. I'm really happy about this topic. One of my favorite topics in Cosmos DB, actually, because it really expands and the capabilities of Cosmos DB. That it makes you think it's not just a simple, NoSQL database. That you can do so much more with it because of this feature. So I'm really looking forward to, deep diving into this topic today.
I couldn't agree more. I think change feed is really fantastic. And last week, I've told the audience that one of my favorite features is around indexing and positive indexes in Cosmos DB. That was not a lie, but in all fairness, change feed is definitely one of the very top, maybe two features in Cosmos DB. So I'm super excited about this one myself. Now, this show and this series is so much more about us hosts and you, the audience. There's an army of people who put up the great work behind the series in every single episode. And we do say hi to our moderator today, who happens to be Mark Brown, the principal program manager for Cosmos DB, as well as to every single other producer who has put a lot of hard work and effort into making this entire series a fantastic series of episodes where you guys can learn more about Cosmos DB. Marilag, why do people want to learn more about Cosmos DB?
Aside from being an expert in Cosmos DB, well, you also want to demonstrate your expertise, have a paper that shows I'm an expert in Cosmos DB, and that is through certification. So there's a new certification in town for Cosmos DB, and this whole series, I think it's about how many, Alex? I forgot, lost track, 14 or more, and some more coming.
15, yeah. And I hear that they may be making more over the summer. So I'm pretty sure that we're going to look at the very long series in the future.
Yeah, but it's really designed to help you guys out there to get certified in Cosmos DB. So I really highly encourage you to follow the entire series with this link here, and then watch out for the new series coming up.
Totally. And in all fairness, the entire certification, as people might know already, especially if you have taken any Microsoft official curricula based trainings in the past, is designed so that every single topic, every single subject design, every single objective of the exam is actually covered by one of the Microsoft Learn modules, which is your own self-paced training kit, so to say. This series is actually covering every single one of these topics. So the topic that we're going to focus on today happens to be called Consume an Azure Cosmos DB SQL API change feed using the SDK. So yes, there is a Microsoft Learn module with exactly the same title as our episode today, and I do encourage you to go through that. But don't be fooled into trying to even follow us, because this is live, and doing the module yourself at the same time, because there is going to be a lot of tips and tricks and insights and under the hood information. And most importantly, if you ask me, since this is live, you will have the opportunity of asking questions. And again, Mark will definitely do a fantastic job picking up those questions and answering them in the chat window, whether you're on YouTube, on Twitch, or Twitter, Microsoft Learn TV, you name it. Or alternatively, we can pick up some of these questions ourselves and take them live. Marilak, what are our learning objectives today?
All right. So as we have mentioned, today is all about change feed, particularly the change feed processor in the .NET SDK. So change feed itself, there's a lot of different ways to, to consume the change feed in Cosmos DB. But today we're going to be focusing on the feed processor. So you're going to learn how to work with the .NET SDK, to code a little bit, my favorite part, and of course how to, author a delegate. You will see that later on, in order to handle the batches that changes, a batch of changes in the client side application. So every time there's a change in a Cosmos DB container, maybe you add a document or updated a document, something out there is listening and doing another special logic for you. And this is what we're going to learn today.
Fantastic. I'm so excited about this one. Cool. So let's not waste any more time. Let's actually dive in and kick this off. You've mentioned that we're going to learn about the change feed processor. You want to maybe care to explain us real quick what this is all about?
Right. So as I have mentioned, Cosmos DB comes with this super amazing feature, change feed, that sort of is used to notify any consumer every time there is an change in the different documents inside the container. So for this topic, we're focusing on the SQL API. So the change feed processor is just something that you can use if you're developing a .NET based application. We will learn later what kind of application you can use to host this. But for now, just think about that. Okay, I can use a shared a library with a couple of methods that I can hook up to and write code into and write logic into it to be able to consume these changes from the Cosmos DB container. So that's what we're going to learn today.
Fantastic. I'm looking forward for that. So people, once we complete this module, you guys will learn how to create the change feed processor using the .NET SDK, because as Marlak has already mentioned, we're going to focus on C# and .NET today, as well as author a delegate to handle a batch of changes in the client-side application. But I do wonder if the audience is actually interested in why would you even care about change in the first place? Because if you do a change, well, it's done, right? Why do we even care about, I don't know, like notification kind of environments that something has happened? Maybe can you walk us through some of these design patterns, Marilak?
Sure. So if you are developing an application, so a very simple application, typically you will think there's a UI and then there's an API somewhere, and then your data gets saved in the database, and that's the end of it. So most applications work in that manner. But with the modern applications, we have different design patterns that we're using now, where we're able to kind of decompose our large applications into different modules or different components or different microservices, or just kind of divide the different logic or purpose of our application across different systems or applications. So
Okay.
how do we actually trigger a business logic that is outside the scope of a specific service? For example, let's say you're building a microservice-based application, and let's say for an order, a retail application. So you have a lot of different processes for a retail application, right? And so maybe you want to decompose that into different services. Maybe there's a service that notifies the user. Maybe there's a service that you need to trigger another external application, or maybe you have another service that you use so you can do analytics, or maybe under the hood, you just need to do some low-level processing of data, like moving the data from this retail application to a different storage for archiving, caching, and stuff like that, right?
This actually reminds me of a lot of different scenarios that which we have had. Over the years, especially in the cloud, we have talked about this concept of polyglot persistence, which is the idea of having data in multiple places, because answering the requirements of a recommendation engine would be fantastic if you use a Gremlin API, for instance, in Cosmos DB. Using a key value store would be a good fit for maybe a shopping cart that would work perfectly well in, say, even the storage account with a simple table API where you simply have key value pairs and whatnot. But synchronizing the data along all of these was always difficult, even if you use a cache. Like, that's the most simple scenario ever I could think of. Data synchronicity and data integrity, referential integrity, is actually something that is quite difficult to achieve. And this seems like literally solves the problem, doesn't it?
In a way, yes. And, whenever we encounter these kinds of scenarios and patterns, the developer is always left asking, how am I going to implement this? Because there's a lot of different ways, a lot of different patterns, or a lot of different architecture to implement this. But if we're talking about, the core data, the data movement, I think it's very special that this feature comes with Cosmos DB. I honestly haven't seen it in other products, to be honest, but maybe I'm just biased. But the fact for me that as a developer that I have my database to actually execute or orchestrate this sort of synchronization of data across different systems, I think that's amazing. I think that's pretty impressive. So this is what essentially Change Feed is designed for, in my view. There's so many scenarios.
I do see we have several scenarios here, right? We have effectively trigger notification. I could think of this like event sourcing maybe, or something along those lines as a design pattern. If you're not familiar with event sourcing, then I highly suggest that you go over to the Microsoft docs, where they have the Azure Architecture Center, and they talk about the different design patterns, and event sourcing happens to be one of them. Real-time streaming and stream processing for IoT maybe, and real-time analytics like you have mentioned, data movement, referential integrity, data synchronicity, data integrity, you name it, would be a third big pillar of scenarios. But if we are to unwrap these, maybe event sourcing, I think this would be an interesting scenario right here, where imagine you have some sort of a shopping cart, e-commerce kind of an application, and your shopping cart has a lot of data inside, like obviously the items that you're about to buy, and at some point you want to check out the shopping cart. Well, in the typical e-commerce application, you have to do a bunch of different things, right? One of them is issue an invoice, integrate with a payment API, maybe with PayPal or whatever have you, integrate with some sort of another notification system where you're going to send a bunch of emails, for instance, maybe integrate with yet another system that does whatever else, right? And all of these are their own single responsibilities. Well, put differently, micro responsibilities or microservices, right? One approach would be that you have some sort of a big service that orchestrates all of these, but then you have a single point of failure. If that fails, everything fails. The other alternative is that you have a change which is going to be picked up almost immediately, if possible, and then sent to all of these different microservices, or the other way around, these microservices pull their information from the change feed, rather. And this is a place where, in my opinion, change feed would work pretty well.
Yeah, I quite agree. And also, I mean, when we look at these microservices, it doesn't have to be just, very small, just microservice that's one thing. That can also be the case. And another thing, it could also be a whole application, but just its own domain. It's like if you're building domain-driven design, then you maybe would have an entire service with a lot of different endpoints that's just concentrated in that domain, and that can listen to the same event store here. And then going back to the event sourcing pattern, the idea is that if you use Cosmos DB as your sort of a central event source, then you're essentially, with the pattern with the event sourcing, is that you always just have an append-only data source. So every time there's kind of an operation against a data, an entity, you don't update that data. You store what you have done against that data. So, for example, if a typical, again, retail order processing pipeline. So if you create an order, so you have an order data. If you change any property in that order, or for example, you add an item, it's not like you will change the same document. In event sourcing, you create a new document, and then you can listen. Your microservices or domain services can listen for every single change on that data, which we would call an event. Essentially, you would have a full audit of what has been executed against that particular data, which is, I think, is very powerful because Cosmos DB itself is persisting this. Unlike if you're just using a typical, what do you call this, in like Event Hub or Kafka, like a messaging system, you're not guaranteed that these events will be persisted. So you have a different system to persist this data. But with Cosmos DB, it comes as both. It's both a persistence and then also an event store.
Yeah, I couldn't agree more. And obviously, the list of scenarios just keeps on growing and growing if you come to think of it. Like over here, for instance, we have real-time data movement. And the entire scenario with real-time data movement is that you might have some sort of a CRUD-based application. CRUD stands for create, read, update, delete, of course. And you're pushing your data to the main collection. But as we have talked in our previous episodes, when we talked about partitioning and data modeling with Cosmos DB, unlike relational data where everything has to be normalized, right? Where you have a single source of truth. In NoSQL, and obviously especially in NoSQL technologies which are based on documents like Cosmos DB, what you really want to focus on is having the same kind of information in multiple places to answer the various business logic and requirements that you might have, which effectively means that you're going to end up having multiple stores rather than your single main collection, which all have to be updated. So if you do the update on a single container, for instance, then you can pick up all of those updates and then replicate them on every other second, every third container and whatnot. And this is what sometimes is referred to as referential integrity. So the way I think of this one, for instance, is let's say you have a bunch of products, right? All the products have categories, and now you want to update the category. Well, without a shadow of doubt, probably in your e-commerce application, there's going to be a drop-down of sorts, maybe a facet in the product browsing view or whatnot, where you only want to know about a product. So supposedly, it would make sense to have a collection of sorts somewhere, maybe on a partition, where you only have information about categories of those products. Those might be a few dozens, a few hundreds, depending on how large your e-commerce application is. But if you're changing something in these categories, rather than doing a reference as you would have done in, say, SQL Server, where you're going back by an identifier to the category, which means that now you're picking data and running multiple queries at the same time, you want to copy the information of the category within the products. But if you have thousands, hundreds of thousands, millions of products, changing that would be rather difficult unless you knew exactly when the product category has changed and what exactly you need to change. So you just have a single service of sorts, for instance, which picks the change of the category and then automatically updates every single product that contains that category information within their document. So this would be super, super useful and easy to use. But again, the real-time data movement can be useful for other scenarios as well.
Yeah.
Any other scenarios you can think of?
Yeah. So you mentioned about referential integrity, but also you mentioned a little bit about partition and accessing data based on a particular partition key. And sometimes your query is very efficient. Of course, I think if you're not that new to Cosmos DB, you know that your query will be very efficient and more economical if you're querying on just a single partition. But so, for example, in order, if I want to get all the orders by the order ID, and then you have a container that is what do you call this? That's partitioned by order ID, then you can query that container, and that's going to be cheaper. But what if you started having a query, or you want to query orders by city? So if you do that against the order container partitioned by order ID, that's going to be very expensive because you're going to do a cross partition query. So one of the patterns that you can do in Cosmos DB is to maybe essentially, if you have that kind of, if you analyze one of your read patterns and you have a frequent read pattern by city, then maybe it pays off to have a separate container where the partition key is by city, and then you would have all the orders connected to that city. So if you have a query, get me all my other orders for this city, you will essentially query that container instead of the other one. But then that's essentially a replication of data again to another container with a different partition key. And change feed is also very good tool for doing this, for executing this. So that's another scenario we can think of.
Yeah, really. I mean, we could probably brainstorm for the rest of the night or day or whatever time zone you're in of different scenarios where this might turn out to be super useful. Because at the end of the day, the important part here is not to have yet another compute service of sorts, a virtual machine or an app service or something like that, that would orchestrate all of these changes and pick them up and keep track of them. Because you could, if coming to think of it, you could programmatically write the same thing yourself, but it would cost you a lot. Like literally, it would cost you a lot. It would be difficult to handle. It would be difficult to track. And everything is just built in. I mean, it's a no-brainer that you want to use change feed for any kind of these scenarios and more. I say maybe it's a good time to actually understand how change feed actually works in the SDK when you're about to implement it in .NET. So maybe let's do that. So one thing to point out is that the .NET SDK actually for Azure Cosmos DB SQL API, of course, ships with a change feed processor that entirely simplifies the task of reading the changes in the feed. Now, I know we have referred to this feed as pretty well, it's a noun at the end of the day, and we've referred to things as something that is materialized somewhere in a place. But the idea is that the change feed processor is the one that actually natively supports a distributed scenario where event processing responsibilities are going to be shared across multiple consumer client applications in an efficient manner. And there are four main components that are super, super important to the change feed. First one, obviously, and the most no-brainer one, I would say, is the monitor container, right? The monitor container has the data from which the change feed is going to be generated. So a change occurred, boom, we have the monitor container knowing about the change, and any inserts, any updates to the monitor container will be automatically reflected in the change feed of the container. The other one that I could think of is the lease container. The lease container acts as a state storage and coordinates all the processing, the change feed across multiple workers. And the lease container can also be stored in the same account as the monitor container if necessary, or it can also be stored in a separate account. And the reason for that is just making sure that you're not consuming potentially any of the RUs that are necessary, or maybe you want to further efficientize and operationalize your containers by isolating their own consumption. Then you have the compute instance or the host. Sorry about that, which hosts the change feed processor to listen for changing. And depending on the platform, it could be represented by a virtual machine. It could alternatively be a Kubernetes pod. It could be an Azure App Service instance, an actual physical machine. It has a unique identifier, which is referred to as the instance name. And we're always going to refer to that. And in your Microsoft Lure module, they will refer to instance name for the same purpose. And then you have your delegate. Now, delegate here is a concept that actually comes from your C# programming and from .NET, which is the piece of code that actually defines what you, the developer, want to do with each batch of changes that the change feed processor ever reads. And prior to using the change feed processor, you should actually create the lease container that you will reference for configuring the processor altogether. Now, if you are to further understand how these four elements actually work together, here's an example in this diagram. Here we have a monitor container which stores the documents and uses city as a partition. And you will find the same reference in your Microsoft Docs article as well. But long story short, the monitor container stores these documents, uses city as a partition key, and we see that the partition key values are actually going to be distributed in ranges that contain items. Let me bring my fantastic virtual laser pointer here. So here we have all of those partition key values distributed in ranges. So we have cities that start from letter A up to E, and then from letter F up to I, and from letter J up to N, and so on. So there are two different compute instances, actually, that the change feed processor is assigning the different ranges of partition key values to each instance. And it does this to, well, pretty much efficientize and maximize the compute distribution that each instance has. So if you look over at the bottom part at host 1 and host 2, these are our compute instances, and these are actually going to maximize the compute distribution. Each instance will have, as I've said, a unique and different name, and each range is going to be read in parallel as progress happens. And obviously, everything will be maintained separately from other ranges inside the lease containers that you see over here. Now, hopefully this makes a bit more sense now, because I don't know about you, Merlik, but I really feel like it's time to show some code.
Yes.
Let's do that. Cool. So for the purpose of the demo that's coming up, I actually have a bunch of interesting stuff. And the first thing I will do is, you know what, I should have sacrificed a virtual machine in the favor of demo gods in production. No, here it is. I was searching for my Microsoft Edge tab, but thankfully I found it. So here I actually am inside my Azure portal. Everything is in dark mode because, you know, Batman. But long story short, the most important part here is my azure-cosmos-db account. And within my Cosmos DB, I already prepared a few containers, but we're mostly going to focus on a single one, which is our stored database. So within the stored database, there are a few containers, namely the card container. I'm going to expand this one right away. And you will see that there's no data within the card container, as well as another card container called, another container called card container by state, which also is an empty container. There's not much to tell here, except for the fact maybe that if I look over to the settings of these containers, you'll see that, where's that? This is poorly skewing right now. Give me 1 sec. Heading back to settings. So the partition key for the card container happens to be item, and I will explain exactly what the document structure looks in a second. Whereas the partition key for the card container by state container happens to be buyer state. Obviously, the name kind of suggests why this happens. Good. So let me minimize that for a second and bring up VS Code, because within VS Code, I do actually have 2 different applications. I'm going to start off with this one. Within this application, I'm going to generate some data. And the way this works is obviously pretty obvious. If you ask me, it's pretty much a no-brainer. I will effectively just run this application. I already have provided my endpoint URL and my primary keys. Please don't copy them because they are live right now and we don't want to mess this up. But long story short, we are actually going to run this, and whilst this guy is running, it is going to generate some actions. An action effectively is an item, a document that we're adding to our containers. And there are items and states and prices that we're going to randomly pick from, as well as randomly pick an action from this enum type right here that is going to be either an add or a delete or whatnot from within our enumerator. So once we are running this guy, let me actually bring this guy up. I will open up a terminal window, change my current dog folder to this one right here, and simply run a .NET run command. And every single asterisk that you see here effectively reflects a new document that I just added. So for every asterisk, I'm adding documents, and I will let this run for a while now. If I actually head back to my Azure portal, open up the items within the card container, I should already see some data popping up. And there we go. So this is the structure of one of the documents. And remember, everything right now is partitioned by item. In case you're wondering, why would we ever partition by item? Well, maybe the speculation here is it was that every single query is ever going to happen by querying the item or putting a filter or a predicate rather on the item. So that's pretty much it, right? So we're loading this guy up, but now we realized, let's speculate at some point, that there's a new requirement where we actually want to have a new container where we are using a different partition key. As you might know, in Cosmos DB, changing the partition key after you created the container is not possible. So what we're going to do with that, let me first head over to VS Code, stop the application, boom, there we go. And now for the purpose of the second demo, I will actually change my current directory to change feed console. And let's actually bring up change feed console now. So within this code, there are a few changes that we'll have to do. The first thing that I'll do prior to actually running anything in the terminal is that within this main method, I want to ensure that I can consume the change feed that will make use of a lease container. So the way you do that is by effectively creating a container properties for your lease container, as well as a container instance for your lease container. And I already have the code written, so you don't have to see me fat finger this one. But long story short, what I will do is that I am simply instantiating the container properties and then instantiating the container itself, which is, again, my lease container. Just remember, this lease container has the purpose of storing information to allow for parallel processing of the change feed, and, well, acts like the bookmark of where the last process of the change feed ever left off, right? Now, the next part that you will have to do here is, actually, I just realized that this variable is actually incorrect. Sorry about that. The next thing that you'll have to do is ensure that you're creating a builder for your change feed processor. So each time a new change or a set of change, because they happen in batches, each time a new set of change is received, there's going to be a function that will execute, and you define this within the create change feed process builder. And what I'm doing here is that I effectively, in order for my builder to run, I will effectively have to write a piece of code that will start the processor and at some point will stop the processor, right? Because that's pretty much what you want to do to begin with. So let's start a processor right after this piece of code. We have not defined what our processor does yet. We'll get to that in a bit. And then once the code completes, let's maybe actually stop the processor. So for this one, I'm simply going to call stop async. I might be missing some NuGet packages in there for IntelliSense is not really cooperating at this point, but that's fine. Again, demo got production VMs, they have not been sacrificed. So let's go one step further, actually, because as I've mentioned, our builder, our processor doesn't do much yet. Obviously, this is the piece of code where once a new change occurred, we want to make something of it, right? So I'm going to do a couple of things now. The first thing I will do is that rather than using a simple object reference of a function of t effectively, because everything is generic, I will replace this into a cart action because I either want to update or delete or add or whatnot command right there. So I will actually modify the signature of this builder to suit that need. And I do see an extra slash there. I definitely have fat finger something. As I've said, I should have sacrificed something like a production VMs. And once I did that, over here now I have a cart item. So now let's change the code and work with that cart item. So I guess one of the things I could do is simply say, hey, I have a list of tasks, and I'm doing this because I want to, again, parallelize everything and then just wait for all of these tasks at a single shot. And for each one of these inside the destination container where I'm pushing my data towards, I will just create a new item. So again, I have some data in one container. I want to move it over to a different container, and I want this to happen almost instantaneously if possible, but it will happen in batches. So let's actually see this at work. Again, I will just have to double check that my container name, my primary key, my endpoints are there. And once again, the logic of this is once your processor is running, my code is simply take my changes, make sure that you run everything asynchronously, and create a new item within the destination container where I have changed the partition key to be something else, right? Kind of straightforward if you think of it. I did it in steps just to elaborate exactly the concept of how this works under the hood. So with this guy, with this application already written, let's now say .NET run, and we're going to get it up and running, hopefully, unless I fat finger something else in the source code. And I would expect that if this guy connects successfully, there we go. We have our change feed processor running. And at this point, it is just waiting and listening for any changes to occur. Now, there are no changes happening yet, right? So that's actually the reason for why I have two terminals open here. Let me actually run this application one more time. So I'm generating some new documents. And as they happen, let's actually head over here. And now we have them side by side. And you can already, oh, actually, that was this one. Now I messed it up. But anyway, the terminal is, oh, actually, it's over here. This application is adding some new documents, whereas this one is picking up the changes. And at some point, it will have those changes received in batches of 100 and then add them as they occur. So for the sake of the test, let's actually head back in the Azure portal. Let's refresh this card container one more time. There we have it. And if we actually refresh the card container by state, which was previously empty, we're going to see that we're already picking up this data. Not only that, but we have the same information, and even better, it is now actually partitioned by the buyer state instead, which means that in case you have a new feature, in case you have a new requirement where you have to pick up card items by the buyer state, you can now do that. And it only took me, what, maybe 5 minutes to explain and 1 minute to write.
Amazing.
Thank you for that.
Yeah, so there's a lot of concept brought out there, Alex. So we might have to kind of maybe dissect that a little bit, the code, especially for the ones who are pretty new to change feed right now. So what really happened? How did the code really process it? Or what else can I do with it? I mean, we've seen the basic, right, without much configuration or control over, for example, how often does it run, or how many items do we fetch per batch, and things like this. So now it's time for us to maybe go deeper a little bit on the SDK itself. All right. So one of the things you've seen Alex did in the demo is that when he was instantiating the builder, when he was creating the builder, he put the code into as a parameter, like inside the builder. But essentially, you can also do it this way via the delegate. We've been mentioning about the delegate before. So in C#, so it's simply like a method that you can execute with a specific signature, with a specific parameter. So in this case, you're accepting, a collection of some items, in this case, a product. And that would essentially be the list of the documents that are part of a batch that has been changed, that's being sent to your code, and then a cancellation token. So you have this delegate. And then from then delegate, you can then create your variable, in this case, this change of type changes handler, and then assign that delegate to it. And once you create the builder, that's one of the parameters that you pass. You just basically pass the name of the delegate. So you can also do it this way. Or another way is that instead of creating a different method for the delegate, you can also just simply pass an anonymous function for this variable, and that would also work. So there are different ways. It's depending on your coding style. I would definitely prefer the way you did it, Alex. But it depends. So sometimes it can be a very long code and you don't want it to be part of that routine, so you want to maybe separate it. So it depends on the logic that you're trying to do. So because if it's more complex logic, so obviously maybe it makes much more sense to do an implementation of a delegate.
What I usually do is that I keep delegates for the very complex stuff, because otherwise they tend to be, well, a nested block of code within another block of code, and it's difficult to follow because you never actually run through line by line. This only happens when something takes place, because it's a delegate, right, by definition of a delegate. So I usually use delegates when stuff are more complex, and then I just shove them away in a different class, or maybe a different, just a different piece of block somewhere in a private method or something like that.
Right. And one thing that you can note there is like inside your implementation there, your handler there, that you typically want to have a for each to loop through the batch, the whole batch. But this is the time for your opportunity for you to sort of qualify which ones you want to process and not, because with change feed, you're essentially getting everything. You're getting everything from that container, and maybe you don't need every change on every document in that container, and then you probably have some qualifiers. For example, you only want to do something logic if a product is in a certain category, so this is an opportunity for you to do that as well, just so you know that you can't decide which items. It's like you cannot query the change feed based on filters. You will just get basically everything.
Yeah, absolutely. Actually, I've seen, and this is an opportunity to bring up another design pattern, which is very typical to streaming data, called called hot paths, or it has a bunch of different names in all fairness, where you're going through every single change that occurred, and rather than pushing that automatically somewhere, you've effectively analyzed all the changes as an aggregate. So for instance, there might be some reason to persist for a while using a TTL, all the telemetry readings from an IoT sensor somewhere, right? And you persist that, and change feed would be great, because besides storing it in Cosmos DB with a time to live where you delete the data after whatever number of hours, you also are taking that from the change feed, analyzing it as an aggregate. And if you realize at some point that, hey, the telemetry that came in from this sensor was above whatever temperature over a given point in time, you also trigger an alert rather than just moving the data from one port to another. And triggering an alert could be sending a push notification message, changing something on a dashboard, maybe in Power BI somewhere else. You name it. Like, it's super, super, super powerful. I mean, it's coding at the end of the day, so you can pretty much do whatever you like.
Yep. One thing also maybe that I want to bring up here, because now you're writing code, so you have all this bunch of logic. You have to remember that one of the limitations, though, for the change feed is that it doesn't really guarantee that you can get all the intermediate updates on the document. So it will always just give you the latest version of that document. So take that in consideration. So it is possible that by the time that you consume the change feed and there has been some maybe 5 very fast operations against that same document, you will only see the latest one. And that is where I think event sourcing is a bit more powerful, because every change is persisted as a different document. So again, based on your need and use case, this is something that you really need to consider.
Yeah. So once I had the delegate implemented, the next thing I did was to implement the change feed processor. Maybe you want to talk about this one as well?
Yeah, sure. So so you saw that Alex just put that code there. First of all, that he retrieved the container, your monitored container. We discussed that later on. So basically, from the SDK, you can just get container and give the name of the container that you want to monitor. And then the second one, and the important one, is to also get that container, that your list container that you have already created. I do understand, Alex, correct me if I'm wrong, that we're not discussing Azure Functions here, but if you use Azure Functions, there is a parameter there that you can automatically create the list container. But for the change feed processor, it does expect that the list container has been created. But of course, you can still use the SDK right now to create a container if it doesn't exist, a list container. So, but that's just very important to note that you need those two first to access. And then,
yeah, that's spot on. That's a very good explanation. Actually, the next episode will focus mostly on Azure Functions and change feed and how you can correlate and how can take advantage of them. And we're definitely going to elaborate even further on this particular topic. But you're spot on.
Right. So once you have your container now, so one of the methods against your monitored container is to get the change feed processor builder, and I think it's going to be on the next slide. Yeah.
You're right.
So this is the builder, and then from you have your source container, that's your monitored container. You can call the get change feed processor builder, and this is a generic, so you can decide which entity you want to serialize it to. It is actually possible, Alex, that you are watching a container that can have multiple types. So you would only get the ones, of course, that you specify here. And then once you have so there are 2 parameters to this builder. I think I mentioned that earlier. You have to have a unique processor name, and then your delegate. But let's talk a little bit about the processor name. So I think one thing that we need to know is that the concept that there can be different change feed processors, or what we call a deployment unit, that can listen to the same container for different purposes. So if you have, like what we showed earlier before, where you have 3 different microservices listening to the same change feed, each of these microservices probably will have its own processor name. Mm-hmm. But like each of this, sorry, not microservices, but each of the processor, change feed processor, for a specific purpose will have its own processor name. But that doesn't mean that there can only be one instance of that host. As Alex has showed earlier with the pattern, that with the same host, let's say you deploy this in a background job, in an ASP.NET hosted service, for example. So you can still have different instances, compute instances, that has the same purpose, is the same under the same processor, but just scaled out. But the most important thing is that they all have the same processor name for every instance. What is different is the instance name. So here you can see the different properties that you can set with the instance name. If you specify the instance names, that is essentially you have a unique name for every instances that would be part of that deployment unit, that processor unit. And that essentially will, or effectively will, scale out your operation for listening to that change feed. And then that list that you're listening to, it will also be in the same list container, but then you would have different records or documents inside that list container that represents the state of each of the instances. So that's what you call, your bookmark. So yeah, so these are some of the properties. So with instance name that you can set, with list container you can set as well. Then you can configure the name of the list container. And in this case, earlier we have a line of code that gets the container, so that would be this variable. And then the rest of these items in the methods are shown here, we're going to discuss later on from the different manipulations against the builder. But right now, this is the very basic one. Processor name, changes delegate, and the instance name, and of course, the list container.
And I think it's also worth mentioning here that our table is definitely not complete. Like there's a lot of different methods. And in case people haven't caught this yet, this is all Fluent API. Like the concept that we have in C# where we're just calling another method on top of another method on top of another method and so on, just separate them by a single full stop, by a single dot, on the purpose of just configuring how your processor works, because that's effectively what we're doing.
Yeah.
Cool.
Right. So so after we have the builder, what is the life cycle of our processor, Alex?
So the lifecycle actually is pretty much as follows. The normal lifecycle of a host instance. You first read the change feed. And if there's literally no changes to the change feed, then there's going to be kind of a sleep for a predefined amount of time, which is customizable if you use this Fluent code that I was mentioning previously with poll interval, and you use this on the builder. And you effectively are waiting, and then you go back to step number 1. Because there were no changes, now you are waiting for the change feed again. And if you have for a long period of time no changes, this is going to happen, obviously, many times. If there are some changes, for that period of time, it's going to actually collect all of those changes. And afterwards, it will send them to the delegate, which is your method that you have defined previously, just like you explained, Marilag. And when the delegate finishes processing the changes successfully, it just updates the list store. So there's like another bookmark of, hey, here's where we are at right now. Make sure that you don't process these again. It just bookmarks that, it goes back to number 1, and then waits a while again and just repeats the process. I think it's super straightforward, and it's not too mind-boggling, even though you hear initially that there are like 4 steps. It's a no-brainer almost.
Right. And I think it's important to know that with this poll interval that you can control, but by default, if I'm not mistaken, is it every 5 seconds? I think that's
I would have to double check that probably, right. But taken with a grain of salt, I do believe it's 5 seconds. I might be wrong, in all fairness.
All right. Yeah, but it's just good to know. Okay, so with this super awesome tool comes an even more awesome tool, which is the error handling. So of course, the question of the day is, what happens if something goes wrong inside my delegate code? Everybody, I think, wants to know that, right? So the change feed processor is really designed to be very resilient to user code. So it means like, so if you have an unhandled exception, so underneath the hood, there's a thread that's processing that particular piece of code. And if it encounters an error, it's going to stop the processor, or it's going to stop the thread, and then it's going to start a new one. And that thread will again query the list container and look for your bookmark. So where were you? Where did you stop? And from then on, again, feed you the changes. So essentially, or effectively, you're just always getting the same changes that failed from your initial code. And when that happens, it will just keep on happening. And that's kind of a built-in retry mechanism. There's a caveat, though, that if it is the first time that if the failure happens in the first ever delegate execution, then you don't have actually, any state yet. So what am I going to do? I don't know, actually. What am I going to do if I don't have that state? What can we do if failure happens, all right?
In my opinion, the smartest thing is make sure that you keep track of the failure. And we have seen this in other technologies, especially in Azure, like in Azure Service Bus. There's a data letter queue for messages that you're pushing through and are failing. We consider them poisoned messages. And you might have poisoned changes from that regard as well. So you want to keep track of them. So later on, you can debug them, maybe improve your code so that it becomes resilient to these errors. So implementing a data letter queue, as I've said, could be one approach. Making sure that you write code that doesn't fail, adding logic to your delegated code to write documents upon exception to a data letter queue is effectively the way I would go about it. But there is another interesting thing that doesn't necessarily fix the fact or resolve the problem related to having code that fails, but rather monitoring how you progress through. And this is done through a so-called change feed estimator. The change feed estimator is useful in order to monitor the progress of your change feed processor instances as they read the changes or even use the lifecycle notifications to detect the underlying failures. And the way you implement this is that as the change feed processor handles the changes, it functions as a time-based pointer. And the pointer moves always forward in time across the change feed and then sends the batches of changes to the delegate to run the business logic. And we have seen that previously when my code that was picking up the changes was saying initially, yeah, we've picked up 50 changes and then 76 changes and then 100 changes, another 100 changes, and so on. So the change feed processor can potentially be constrained by the physical resources of the host application. And if so, it's almost immediately assumed that the change feed processor should be scaled out to multiple hosts, all reading from the change feed concurrently, all at the same time, multiple consumers patterns effectively. The problem here is that identifying the change feed solution needs to scale out, and it can be difficult, and it also requires an estimator feature. And the change feed estimator is a sidecar feature to the processor that measures the number of changes that are pending to be read by the processor at any point in time. And in order to implement this change feed, you must first analyze the processor. And in this example that you see right here, a processor is actually created with a specific lease container, and then a delegate would handle the changes. And the code that you see effectively, again, creates a source container, creates the lease container by pulling the reference of the container name, and then creates a change feed processor object by specifying the source container .get change feed process builder. And on that particular method call, as always, you specify the processor name, the onChanges delegate, the instance name, the lease container, and you build. And once you have done that, further on, implementing the change feed estimator is pretty much handled by calling this changes estimation handler, which is going to be an async call, obviously a lambda expression here. And once you have that, you would effectively just make sure that you use that estimation delegate as another parameter within your get change feed estimator builder call as a second parameter in this example right here on the third line. So there you have that. I think this is a super powerful thing because, again, it helps you monitor the progress overall and understand better when the need arises for scalability, for scale up and scale out, actually. Mary, Mark actually informed us, and I do appreciate his intervention here because I was a bit torn apart by whether it was a 5 second or a different number. The default poll interval is actually for 1 second, and I want to call this out for people so that we don't get them the wrong information when they're preparing for the exam.
Yeah, that's very good to know.
Would you like to cover the manipulation of the change feed consumption? Because in my example previously, what I have shown people is that I wrote some data, right? And then I was looking into the other container. The data obviously was not there, only in the original, in the source container. And then I started the change feed processor, and the data was still not there until I actually added some additional data. But there are a lot of different scenarios in which you actually want to pull more information in, like information of changes or changes that have already occurred. Can you do that?
Of course, it's possible to really initialize the change feed processor to read changes starting at a very specific date and time. So there's one of those properties you can set, or which is read start time. And then you can just pass a particular date and time to fetch all the changes. And again, this is really powerful. So for example, in a scenario for migration, and then maybe you want to only migrate the data that started in a certain point of time, then this is the, the best way for you to do that. And I think this is also really good to know, because some people who, as you mentioned, who started working with change with things like, okay, so what if my business logic has changed, and maybe I have introduced a new process in my business, in my business process, which needs to consume all these documents, but it's fairly new, right? So if I start a change feed on that processor for that, then I expect to get all the data from maybe not from the very beginning, but where it makes sense. So this is a very good way to use the change feed processor. And then there's also another way. If you want to get data from the very beginning, there's also a way, and that's actually very easy. So instead of just passing a specific date and time, then you can just use in C# at least the date time mean value to universal time, and that's essentially gonna set you back from from the very beginning, which I think is a good kind of time for us to also let you know that what is the life span of a document, how long is it going to be there, how long, as long as you don't delete, as long as a document doesn't have a TTL, then it's going to be there, and you're going to be able to consume it from your change feed. So
yeah, that's a very good point, actually. Now, previously I ran my change feed on my own application, on my own machine. This is a pretty beefy machine. You don't want to spin one of these machines up with the same specs. It's going to be pretty expensive. And there are other ways to obviously host your change feed. You don't want to do it on premises, by for sure. The one place I would put my change feed processor in as a compute, to host my jobs, would be a simple Azure web job, like back in the day when we only had web jobs for background processing alongside your app services. And it still is a fantastic candidate, but in my opinion, even better than that would be an Azure function. But that's another completely different ball play that we're going to talk about next week. Obviously, you might as well spin it up in an Azure virtual machine. If you already have a couple of virtual machines laying around, sure, why not? Leverage them. Make sure that you take advantage of those. It can also be a background job running effectively as a Kubernetes pod somewhere in an AKS cluster, especially if you have already one lying around and your architecture is based on that for other purposes. Maybe you have implemented some meshing or service mesh patterns or whatnot, using the underlying compute resources you have available for also running your change feed processors is going to be a no-brainer. And then last but not least, also an ASP hosted service, that will also be a good job. For instance, if you already have an ASP.NET application running, maybe in an app service, in a web app, for instance, developing a hosted service, which is just an interface that you need to implement at the end of the day within your ASP.NET projects, would be a good place to run these change feed processors. But keep in mind that in these scenarios, you're effectively going to consume the underlying CPU and memory or share rather, both your server backend CPU memory as well as for the one necessary for the change feed. So you want to be a bit mindful on how you monitor and how you troubleshoot the performance of your change feed, so you don't cannibalize the CPU consumption, because this would potentially take down your server backend. Just something to be mindful about. Right. Cool. What about maybe a quick knowledge check, Marilyn? How do you feel about that?
Sure, let's do it.
This was definitely a bit technical today, at least in comparison to the other episodes that we have had so far. This was a bit more technical, more code, more explanation. Hopefully people got it. And I do want to remind everyone that you should head over to aka.ms/polls and actually interact. Tell us the answers, and we'll make sure to listen in and double check that with the actual answers. Do you mind if I take the first one?
Sure.
So the question asks, which method of the container class is used to create a new change feed estimator? Is it A, get change feed processor builder, which is a generic method? Is it B, get change feed estimator builder as a non-generic method? Or is it C, get change feed iterator as a generic method? What do you think about this one?
I think because it's estimator on the question, then I'm going to go with B.
Is that B, estimator? because of
Yeah.
the noun you mean?
B is the get change feed estimator builder.
Get change feed estimator builder. It sounds like you're guessing there, aren't you?
No, it's just because I'm kind of, if I'm, doing the exam, the certification, this is something that can be quite confusing, right? Like, wait, this is .NET code, and then you just look, okay, what is the difference here? But I'm pretty sure it's B. It's get change feed estimator builder.
You're actually absolutely correct. Get change feed estimator builder is the method that will actually construct an estimator, and that estimator will run side by side with a processor. So if people answered processor, that would have been an interesting guess, because that's what you build your processor with. But here the question specifically asks on the estimator, right? So in all fairness, the names are rather similar. So it is a very tricky question from that regard. You really have to pay attention to all the right words in the question.
Exactly. Okay, I think it's my turn to ask you. Which
Yeah,
method of the
right.
change feed processor class should you invoke to start consuming changes from the change feed? A, is it get change feed processor builder? B, start async? Or C, build?
Okay, so when I wrote the code, I remember calling build at some point, but that was only to build effectively either the processor or the estimator, whatever have you, depending on the scenario. I do remember calling the get change feed estimator builder, but again, the purpose there was to initialize the builder rather than, as the question asks, start consuming the changes from the change feed. And as people might remember, at some point I had whatever object of that processor type. In my example, it was called processor, that I did call start async on, and when my code stopped, I did call stop async on. So given that example that I presented earlier, my personal take would be, as the audience says as well, start async. And we do have 100% vote on B. So let's double check. Yoo-hoo, we are actually correct. How do you feel about change feed, Marilag? Is it still your favorite feature?
Oh, definitely. And I think I even learned way more than what I knew before this show. So this is also helping me a lot. And I hope that, that it got your interest, the audience here, and that you will kind of spend more time building something cool and useful with the change feed processor. But it's definitely a favorite topic. And I think actually 1 hour isn't enough to cover everything. But that's why there's another session as well regarding
We
change
do have
feed and the
another
Azure
episode on change
function.
feed.
Yeah,
We
exactly.
definitely do.
Yeah.
And in all fairness, we barely talked about change feed today, if you come to think of it, because we barely even touched the surface, the tip of the iceberg. We have, however, learned how to create a change feed processor in the .NET SDK, as also how to author a delegate to handle a batch of changes in the client-side application. And if people in the audience want to learn more, I would encourage them to learn more by scanning this QR code or heading over to aka.ms/learnlive-2022 0406A-summary. For more information about all the topics that we have discussed so far, I would encourage you again to look over these links, and they will take you to the change feed overview and documentation in Azure Cosmos DB, the change feed processor documentation, as well as the utilization of the change feed estimator. I don't know about you, but I've had a lot of fun. And I do want to remind people that there is a fantastic opportunity to actually, at a self-paced training kit, effectively, go at their own pace over the Microsoft Learn module called Consume an Azure Cosmos DB SQL API change feed using the SDK. And I do want to stress out, people do not have to have an Azure subscription to learn about these technologies. They don't need to have to pay anything. They don't need a credit card or any of those sorts. They just need to sign in with their personal Microsoft account, which is completely for free. And they can even do the labs associated to every single one of these Microsoft Learn modules. What they're effectively going to get is a sandbox environment with a virtual machine they can log in with an Azure account, with an Azure subscription already prepped up for them to actually go through all the instructions, which are step by step, and they will teach you exactly how to use change feed in this scenario.
Yes.
Very nice. Again, I don't know about you, but I've had a lot of fun. And I do want to remind people that this is a series of 15 different episodes. So make sure you don't miss the next one, also on change feed, when we're actually going to talk about handling events with Azure Functions and Azure Cosmos DB SQL API change feed. Now,
are you part of that? Sorry, are you part of that for the next session?
Yeah, thankfully I will. I told you, change feed is my favorite topic. So I wouldn't have missed that for the world.
All right. Well, good luck with that. I'm sure it's going to be fun.
I'm sure it will be fun, and it will be fun as well because I'm co-hosting, regretfully not with you that time, but with Glenn Colpart. But that does bring me good memories because the very first episode of this series actually happened in December 2021, and it was with Glenn as well. So it's going to be a bit nostalgic for me. Marilek, did you get certified yet?
Oh, that's an embarrassing question. Not yet, but that is definitely on my to-do list very soon. I'm just going to take a short break for the Easter. I'm traveling to the Philippines, and then I'm going to focus to get certified Cosmos DB, definitely. What about you?
I didn't get certified either, in all fairness. But there's another explanation and reason for that I'm going to take offline for people who are going to reach out over Twitter, and they'll understand why I didn't get certified yet. Not because I didn't take the exam, but because I was prohibited to an extent by writing some of the exam questions. But that's a different conversation. Yeah. But I do want to stress out that actually the exam came out of beta just 2 weeks ago. So people can now actually take the exam and going to find out the result on the spot, whether they passed or not. And I do want to remind people that there's a second shot opportunity they should look out for so that they can take the exam twice. It's going to be a bit more pricier than paying than a single shot exam, but it's going to be much cheaper. So, and that's actually my take usually to the full price exams, where I buy one of these offers, I take the exam the first time, I know what I'm set up for, I know what to focus on, and then I go back to the recordings on YouTube of all of these series and I watch them, I learn more, I go through the Microsoft Learn modules, and then I'm fully prepped and take the exam one more time. That's my usual take to it.
Yeah, that would be the same for me. And for what it's worth, it's always a learning experience, whether you pass or not. Every single iteration you do, every time you watch these videos, you discover something new. So keep on watching.
How many hours will you travel to the Philippines?
Oh, for this time, I think it's 18 hours. First
18
time
hours?
in 2.5 years. Yeah.
That's fantastic. Enough time for you to watch all the recordings and get ready for the exam.
Are they downloadable offline?
Maybe we can figure something out for you.
That's for the Cosmos DB Learn Live team. That's a hint. Downloadable study hall. What do you call it?
You definitely have to pass that feedback along for sure.
Yeah.
Now, since we don't have any more questions, Mark did a fantastic job answering all the questions so far, and we do thank him for that. And we do say hi again, and we salute everyone in the production team and everyone who was hard at work actually to put this series together. And again, my name is Alex. It was a pleasure having you with me, Marilek, for this fantastic episode. Safe travels to the Philippines and stay safe, everyone.
Thank you. Stay safe, everyone. Thanks, Alex. Bye.